Hi, my name is Razwanth, and today I'll be discussing Akil and I's second mini project, which is the Water Contact Angle Mini Project, and this involves testing hydrophobic and hydrophilic properties of two different materials. The goal of this experiment was to measure water droplet contact angles and determine roll-off or sliding behavior in order to assess how these materials interact with water, which will end up giving additional insights into their surface properties. The materials we chose to test were a wax-coated wooden ruler and a standard plastic ruler. And before even beginning the experiment, we had a hypothesis that the wax-coated wooden ruler would exhibit more hydrophobic properties, while the plastic ruler would exhibit more hydrophilic properties. And so here you can see the contact angle measurements on the wax-coated wooden ruler. The water droplets had contact angles greater than 90 degrees, with an average of 96. This high contact angle indicates that wax-coated ruler is hydrophobic, as the water droplets tend to bead up on the surface instead of spreading out. And next, we measured the contact angles on the plastic ruler. Here, the water droplets displayed angles of less than 90 degrees with an average contact angle of 32 degrees. These lower angles suggest that the plastic ruler has hydrophilic properties which allow water to spread more easily across the surface. Now, we will go over the differences between the hydrophobic and hydrophilic materials. The wax-coated ruler, shown here, forms water beads with higher contact angles indicating hydrophobicity. In contrast, on the plastic ruler, the water droplets spread out more, which is characteristic of a hydrophilic surface. These close-up images highlight the difference in wetting behavior between the two materials. Analyzing these results, we can see that the wax coating on the wooden ruler repels water due to its non-polar nature, causing the droplets to bead up. The plastic ruler, on the other hand, is somewhat polar, which encourages water to spread. Since water is polar, it interacts more readily with surfaces that have similar polarity, showing how material chemistry influences surface interactions. So for the next part of the experiment, we measured the roll-off and sliding angles. So for the wax-coated wooden ruler, the droplets began rolling off at an average angle of 28 degrees. In contrast, the droplets on the plastic ruler started sliding at a higher average angle of 35, indicating different movement behaviors on each surface. The wax-coated ruler shows roll-off behavior, which means that droplets move quickly down the surface when tilted. In contrast, the plastic ruler demonstrates sliding behavior, where droplets move gradually when the ruler is tilted. This difference in behavior is influenced by each material's interaction with water and also its surface texture. Finally, let's look at potential applications for these properties. Hydrophobic materials like the wax-coated ruler could be used for waterproof coatings, anti-fogging surfaces, or easy clean products. On the other hand, hydrophilic materials like the plastic ruler are useful in medical devices and applications where controlled spreading of water or other fluids is required. Understanding these properties helps us design materials for specific purposes based on their interaction with water.